Video number 1, an introduction to radiation. Welcome to the first educational video about the science and application of radiation. This first video will be an introduction to the concept of radiation. We will talk about what radiation is and how radiation behaves. Before we get going talking about radiation itself, we first need to understand the idea of the atom. Knowing what an atom is and what it looks like is important for understanding how radiation interacts with objects. Seen here is a picture of an atom. All matter in the universe is made up of atoms. The sun in the sky, the ground underneath our feet, an apple you eat for breakfast, your television, and even your body. All of these things are made up of atoms. Atoms have a very specific structure. The center of the atom is called the nucleus. You can see the nucleus at the center of the atom here in this picture. The nucleus is made up of two small particles, protons in red and neutrons in gray. Electrons, seen here in blue, orbit around the nucleus. There are over 100 different types of atom, and you have probably heard of some. Oxygen, nitrogen, carbon, sodium, potassium, hydrogen, helium. These are all different types of atoms called elements. Atoms of these elements come together and form bonds to make up everything around us. Radiation is something different than atoms. Radiation is best thought of as the movement of energy through space. This movement of energy can happen in a few different ways. Shown here are two different types of radiation, particle radiation and wave radiation. Both of these types of radiation represent the movement of energy through space. You might be surprised to learn that you actually encounter radiation every day. The heat that we feel from the sun is one example of radiation. The light that comes from the sun or a light bulb and allows us to see is another form of radiation. So are microwaves that we use to warm and cook our food, or radio waves that allow us to listen to our favorite songs. All of these are different types of radiation that are moving through space all around us. Not all radiation is the same. We've already discussed how some radiation comes in particles and others in waves. Another difference is that different types of radiation carry different amounts of energy. Shown here is a spectrum of different types of wave radiation based on how much energy each type has. The categories on the left, starting with radio waves, have the least amount of energy, while gamma rays on the right have the most amount of energy. How much energy is contained in radiation is important for understanding what happens when radiation interacts with an object like you or me. The radiation here is classified into two types, based on how much energy is contained in that radiation. In blue, with low amounts of energy, we have non-ionizing radiation, and in red, with high amounts of energy, we have ionizing radiation. How much energy is contained in radiation tells us what happens when that radiation hits an atom. When radiation is moving through space, it will eventually collide with an object. The energy that is contained in the radiation will then be transferred from the radiation to the atoms in that object. When ionizing radiation hits an atom, so much energy is transferred that electrons can be knocked away from their orbit around the nucleus. This can change the atom and can also cause the connections or bonds between atoms to be broken. On the other hand, non-ionizing radiation does not contain enough energy to remove electrons from their orbit around the nucleus. It is the process of electrons being removed from atoms and bonds between atoms being broken that makes ionizing radiation particularly dangerous. This means that ionizing radiation is much more hazardous and dangerous to our health than non-ionizing radiation. Here are some examples of wave and particle radiation that are ionizing. Under the wave types are ultraviolet, X-rays, and gamma rays. You may have heard of some of these before. X-rays, for example, are used by doctors and dentists to take pictures of our bones and teeth. Alpha particles, beta particles, and neutrons are types of ionizing particle radiation. Sometimes we want to block radiation and stop it from moving. For example, when you get a dental X-ray, you might be covered by a lead blanket. That blanket stops the X-rays from hitting other parts of your body. Just like different types of radiation have different amounts of energy, they also have different sizes. These differences mean that different types of radiation are easier or harder to block. Some types of radiation are very easy to stop. For example, alpha radiation can be stopped by as little as a single sheet of paper, and beta radiation can be stopped with a sheet of aluminum. Other types of radiation are more difficult to block. A thick layer of lead is needed to stop X-rays and gamma rays, and thick layers of concrete or water are needed to stop neutron radiation. Knowing how we can block radiation is important for keeping people safe around radiation sources. We will discuss more about these sources in later videos. The final idea for us to discuss on the science behind radiation is whether radiation can make things radioactive. When something is radioactive, that means that it is actively emitting radiation. But just because something is exposed to radiation, that does not necessarily mean that that object itself will become radioactive and start emitting radiation. Except for in special circumstances, alpha, beta, gamma, and X-ray radiation are all unlikely to make another object become radioactive. This means, for example, that these types of radiation can be safely used to sterilize food or medical equipment without causing those objects to become radioactive themselves. Neutron radiation, on the other hand, is more likely to make other objects become radioactive. This is because of the special way that neutron radiation interacts with atoms. It can cause those atoms to start emitting radiation themselves. Non-ionizing radiation, like radio waves, does not make other objects become radioactive. To check your knowledge about the science of radiation, try to answer these 5 questions. You can pause the video to think about the questions for as long as you like. When you are ready to see the answers, press play.